the parameters of water quality. So here we'll look into the types of the parameters that we have for the physical, chemical, and biological water quality. Okay, the first one is about turbidity. Turbidity is easy because you have this turbidity meter. It's the cloudiness of water. So you measure the ability of light to pass through water, and this turbidity is caused by suspended materials such as clay, silk, organic material, plankton, and other particulate materials. Okay, why is turbidity a very important water quality parameter? First, it will increase the cost of water treatment because we have this because it is suspended material. So it provides hiding places for harmful microorganisms. Suspended materials can clog or damage fish gills, provide absorption media for heavy metals and many hazardous organic pollutants, reduce available food because higher turbidity raises water temperature and thus lower DO. Because by having this turbidity, usually you have these microorganisms, and these microorganisms will take up the dissolved oxygen, the dissolved oxygen of the water body, so it will lower the DO in the water body. Okay, so the measurement is using nephelometric turbidity meter. So usually the unit is NTU or TU. TU is equivalent to 1 milligram per liter of silica in suspension. Okay, how do you look at, let's say if you have a sample of water, so you can guess, you can guess the turbidity value of this sample by looking at the sample, whether it is if it is visible to average person, it's 5 NTU. But if it is the turbidity of the water is like in muddy water, then you know that the NTU exceeds 100 NTU. So this is turbidity parameter. And then temperature. Temperature also very important because it will affect the sedimentation, chlorination process, BOD, bioabsorption process. They are all temperature dependent. Most people find water at temperatures 10 to 15 degrees Celsius most palatable. Okay, so because the sometimes like the ammonia, if it is free ammonia in the water body, if it's at high temperature, it will go to the free ammonia, which is no, it's if the temperature is ambient temperature, then you will get free ammonia. But if it is at high temperature, we will get ammonium ion. So this one, it is harmful to human and also to aquatic organisms. So this is why temperature is, because sometimes if the ammonia is there, the ambient temperature is okay, but suddenly there is industry, flow from industry to the rivers, which has high temperature, it will increase the temperature of the water body, and it will affect the chemical reaction of the ammonia present in the existing water body. So color is also important because its materials decayed from organic matter. Sometimes it's okay, but because it is not aesthetically acceptable. So color is measured by comparing the water sample with standard color solution or colored glass disc. So one color unit is equivalent to the color produced by a 1 milligram per liter solution of platinum, potassium chloroplatinate. This is the probe. Okay, apparent color is the entire water sample color and consists of both dissolved and suspended components. So the color is graded on scale 0, very clear, to 70 color units. So let's say if you find any river water with this high color units, then you can take this characteristic of the river water to be the water that you want to treat for your design project. Okay, taste and odor caused by foreign matter such as organic materials, inorganic compounds, or dissolved gases. These materials may come from natural, domestic, or agricultural sources. Sometimes if it is from organic materials, mostly they are not harmful, but it is not pleasant to have this. It's not palatable. We call this. It's not palatable for human consumption. Okay, solids. Solids. This is very important for you to understand this chart, because sometimes it is reported in the characteristic of water. A source of water. Sometimes they give the total solids. Sometimes they give the TDS, total dissolved solids. Sometimes you get the SS. So you need to understand what does this mean. Total solid is total dissolved solid plus total suspended solids. So if you get a sample and you just evaporate the sample, then this is the total solid. Like you put your sample, water sample in a crucible that macam mangkuk tu, and then you evaporate. Then this is the total. This is a total solids. But then if you filter using glass fiber filter, and you evaporation of filter, you will get the one the supernatant will be the total dissolved solid, and the what you have in the filter paper is the total suspended solids. So the total dissolved solids, if you put in the muffle oven, then you get VDS. VDS is volatile dissolved solids. Volatile dissolved solid, and you get FDS. Is fixed volatile solid, a fixed volatile solid, where you get in the after you go through the muffle oven. Muffle oven meaning that it is at 550 degrees Celsius. Evaporation meaning it is using only the oven at usually 105 degrees Celsius. So this is the different, because the treatment of the different types of solids that you find in the characteristic of water source is different. How you want to remove total solids, how you want to remove total dissolved solids. Maybe total solids is not difficult. You can have filtration, you can have clarifier. But total dissolved solid, there is a way that we'll study one by one of the unit operation that can remove the total dissolved solids. Okay. And then electrical conductivity. What does this mean by electrical conductivity? It measures the ability of a solution to carry or conduct an electrical current. Since the electrical current is carried by ions in solution, the conductivity increases as the concentration of ions increases. So EC can be used to estimate the total dissolved solid value. Sometimes it is not that accurate, but total dissolved solids, the major component, the major components of total dissolved solids is from the ions, from these metal ions. So that's why they can conduct electrical current. So it can be an estimate of TDS value of your wastewater sample. So the US units for EC is micron horse per centimeter. SI units millisiemens per meter or decisiemens per meter. Okay, so you can use both unit to, but it's better to use SI units. Pure water is not a good conductor of electricity. Typical conductivity water. So if you measure water sample, so if the conductivity drinking water. Class, can you hear me? Hello, class,
Yes,
can you
Prof.
hear me?
Yes,
Oh,
Prof.
okay. I thought because there's just now there is a internet. My internet is missing just now. Okay. Okay, and then we have another. Just now is sorry. It's a physical parameter. Now we have chemical parameters of water quality. So pH. I think all of you knows about pH from 1 to 14. 14 the most alkaline and 0 or 1 or most acidic. And 7 is the neutral pH. So pH is a very important for maybe the first parameter that you will need to assess to indicate the type of source water that you have. Heavy metals such as cadmium, lead, and chromium dissolve more easily in highly acidic water. Many heavy metals become much more toxic when dissolved in water. A change in the pH can change the form of some chemicals in the water. Therefore, it may affect aquatic plants and animal. Okay, sometimes we have compound containing cadmium, lead, and chromium. It's there already, but at neutral pH is okay. But then suddenly we have this discharge from industry that is very acidic, and it will affect the heavy metals already present in the water body to become toxic. So if you see that the pH is less than 4, you know that it is a severe danger of health effects due to dissolved toxic metal ions are expected. So usually the water tastes sour. So pH less than 4. Very important that you know needs to be increase or decrease the pH. At pH 4 to 6, toxic effect associated with dissolved metal also, including lead, are likely to occur with water taste slightly sour. So the water target is to have the pH range from 6 to 9 so that you don't have any significant effects on health. pH 9 to 11, the probability of toxic effect associated with deprotonated species increases sharply. So this one bitter. Greater than 11, like when you have this, usually if you have textile wastewater, textile wastewater industries like textile, the pH is very high, 11. Severe danger of health effects due to deprotonated species. So water tastes soapy. Treatment option would be the addition of an acid or an alkali. So let's say if you have pH about 11, then you have to add acid. Only HCl will work with this pH greater than 11 because if you use very mild acid, you need to input so much of this, the amount of this acid, so much of this that usually it is not economical. So let's say if you have pH greater than 11, I would suggest that you try to find something natural, maybe natural coagulant. Okay, that's why I think I want to put in your marks for your design project. Let's say if you use something that is not common, let's say usually we use coagulants like lime, soda, but if you use something that is different and you try to find from literature, I will give you extra mark for this. Okay. Okay, inorganic matter. What does inorganic matter means? Carbon-free, not derived from living matter, and easily dissolved in water. They are mineral origin. So usually it's not harmful. Include acids, bases, oxides, salts, etc. Several inorganic components are important in establishing and controlling water quality. Two important inorganic constituents in water are nitrogen and phosphorus. So, and also we have inorganic matter like acids, lemon juice, vinegar, sour milk. So this is the relative strength of acids in water, based on the dissociation of hydrogen ion in water. Okay, bases also is inorganic. Base is substance that produce hydroxide ions when dissolved in water. Like or common soap, bitter things contains bases. So this is the type of base substance in water. Salts also inorganic. When acids and bases chemically interact, they neutralize each other. Okay, these are parameters that you need to know in your water source. Acidity, I think it's already here. Yeah, acidity, bases. Well, acid is alkalinity actually. So acid neutralizing capacity comprised of the total of all titratable bases. So this is acidity and alkalinity for the bases are also important parameter that you need to understand when when you characterize your water source. So sometimes you need to make sure that you neutralize when the water source is very acidic or very alkaline. Okay, chloride occurs naturally in groundwater, streams, and lake. Presence of relatively high chloride concentration in fresh water, about 250 milligram per liter or more, and may indicate wastewater pollution. So they may enter surface water from several sources, including chloride containing rock, agricultural runoff, and wastewater. Chlorides are not usually harmful to people. However, the sodium part or table salts has been connected to kidney and heart diseases. So if you have the chloride is okay, but usually chloride will be combined. So it will be present in the water body as a salt. Usually the sodium part is the one that will affect your health. So salty taste sodium chloride 250 milligram per liter. Magnesium or calcium chloride only if if they reach 1000 milligram per liter, then you will get the salty taste. The common measurement is using titration method by silver nitrate. Chlorine residual does not occur naturally in water, but is added to water and wastewater for disinfection. This is the chlorination. While chlorine itself is a toxic gas, in dilute aqueous solution, it is not harmful to human health. In drinking water, a residual of about 0.2 milligram per liter is optimal. So actually, we need to have this some residual in the drinking water, because we just want to make sure that during the distribution, we still have this disinfection properties of this chlorine. We have enough chlorine to disinfect whatever bacteria that we have during the distribution of the water supply. Okay, sulfate ions occur in natural water and is in wastewater. Actually, there's no significant danger to public health, but sometimes because the taste of the water source, that meaning that it is not acceptable. It is not acceptable for human consumption. So we need to remove if you have more than required sulfate in your water characteristic. Nitrogen also forms of nitrogen in water and wastewater. Okay, usually in water and wastewater, you have organic nitrogen, ammonia nitrogen, nitrite nitrogen, and nitrate nitrogen. Okay, total nitrogen is the summation of organic nitrogen plus inorganic nitrogen. What are inorganic nitrogen? They are ammonia nitrogen, nitrite nitrogen, and nitrate nitrogen. Okay, usually in the lab, if you want to measure organic nitrogen, you will do two tests, TKN, total Gidal nitrogen, and also ammonia nitrogen, because total Gidal nitrogen is the measurement of organic nitrogen plus ammonia nitrogen. So when you do another test, ammonia nitrogen, then you will be able to get the actual organic nitrogen. Do you understand? So if water is contaminated with sewage, most of nitrogen is in the form of organic and ammonia, which are transformed by microbes to form nitrites and nitrates. So nitrogen in the nitrate form is a basic nutrient to the growth of plants and can be a growth limiting nutrient factor. Okay, so nitrate is good for plants, but not too much, because too much it will cause eutrophication. But excessive nitrate concentration, more than 10 milligram per liter in drinking water, is dangerous because it will cause an immediate severe health threat to infants. Because this nitrate, it will disturb, with the oxygen in our body, so it will prevent the oxygen from reaching our our brain. So this is what we call blue baby syndrome. Blue baby syndrome, because of this nitrate consumption of nitrate in your drinking water, more than 10 milligram per liter. Then we have fluoride. Moderate amount of fluoride ion in drinking water contributes to good dental health, about 10 milligram per liter. Okay, so it's good to have fluoride in your drinking water because it is for our taste. But excessive amount of fluoride cause discolored teeth, a condition known as dental fluorosis. So you need to know what is the maximum allowable levels of fluoride in public water supplies, because, and then this differ whether we are talking about the sample in cold climates or tropical climates, because the concentration of fluoride for potable water is only 1.4 milligram per liter, but in colder climate up to 2.4 milligram per liter is allowed. Okay. Iron and manganese also usually in groundwater, so they do not cause health problem, but impart a noticeable bitter taste to drinking water, even at very low concentrations. And also you can see that if it is used for laundry, and it will cause black or brown stains. So make the water not suitable for washing of our laundry. And also it will cause brown stain in plumbing fixtures. Okay, this is iron and manganese. And then you have copper and zinc. Non-toxic if found in small concentrations, because of course, you need some these trace element metals as your nutrient for our body, but cause undesirable taste in drinking water, and at high concentration, zinc imparts a milky appearance to the water. So measured by the same method used for iron and manganese measurement. And then hardness, also it's not, we have to ensure that our water supply contain not so much of this hardness parameter, because it will cause problems such as scale deposits in hot water pipes and difficulty in producing lather with soap. So if the water is hard, then when you wash, you'll not be able to see all these bubbles, the soap bubbles. Okay, so you feel that it is not clean. These ions are present as bicarbonate, sulfates, and sometimes as chlorides and nitrate. Okay, generally groundwater is harder than surface water. So I would expect that some of the groups will choose groundwater to treat, and not only surface water, because we will learn these various sources for the treatment. And of course, you will need different unit operations for this. Okay, and then dissolved oxygen, it is very important. So when you measure the dissolved oxygen in river, if it is about 8 to 9 milligram per liter, then you know that the river is very clean. So the actual amount of dissolved oxygen varies depending on pressure, temperature, and salinity of the water. So the main methods for measuring dissolved oxygen, because this is a very important parameter, like the pH, meaning that this is the easy parameter that determines the water quality. You can use the colorimetric method, quick and inexpensive. Usually you have this probe, Winkler titration method, traditional method, or electrometric method. So usually you just bring the probe and you can see what is the dissolved oxygen value in the water body. Okay, in your samples. Biochemical oxygen demand, I think especially those of you who have taken wastewater treatment course, you are very familiar with BOD. Bacteria and other microorganisms use organic substances for food. As they metabolize organic material, they consume oxygen. So meaning that the BOD is the measurement of the waste, organic waste that are biodegradable by microorganisms. So the organics are broken down into simpler compounds such as carbon dioxide and H2O. So usually you measure BOD, BOD5, BOD5. Why we measure BOD5? Because BOD ultimate, you can see this is the very steep portion of the measurement until 5 days. Otherwise, you have to measure until maybe 12 days to for this to reach the steady state, but you will take almost more than double of the time for the measurement. So that's why you always use BOD5. But by having BOD5, you will be able also to estimate what is the BOD ultimate of your samples. Okay. Okay, COD. COD is a parameter that measures all organics, the biodegradable and non-biodegradable substances. So they will use strong oxidizing chemicals like potassium dichromate, sulfuric acid, and heat. And the results can be available in just 2 hours. Okay. So most of the time you use COD, but for the same types of water, the COD to BOD ratio will be about the same. So usually if you cannot sample throughout your, let's say if you want to get the value for both the BOD and COD, you will have a few samples for both BOD and COD so that you get the ratio, and then you will only monitor BOD maybe in 1 week once, and then the rest you measure the COD, because COD will only take about 2 hours. Why measurement of BOD and COD is very important? Because BOD means that the organic are biodegradable. COD, they are due to strong oxidizing chemicals. So if you have a very high COD to BOD ratio, meaning that COD is very high. COD is very high indicates that you have non-biodegradable substances or hard to degrade substances in your water body, and you can usually, it is associated with the discharge from industries, because most of the discharge from industries, they are not biodegradable. Okay, so you know, if the COD to BOD ratio is very high, more than 3, then you know that you have non-biodegradable substances or hard to degrade substances in your water body. So the type of treatment that you will choose will be different. Okay. COD values are always higher than BOD values for the same sample, but BOD can sometimes be higher than COD values if you have algae in your sample. Okay, so all these parameters need to be measured, not only one, because you want to determine the types of sample that you have. Toxic inorganic substances. Okay, just now we talk about inorganic substances. So most of the time, inorganic substances like lipids, carbohydrates, they are not they are not harmful. Some toxic substances occur from natural sources, but many others occur due to industrial activities, and improper management of hazardous waste can be divided into 2 groups. You can have metallic compounds, and the measurement is using atomic absorption photometer, spectrophotometer, or inductively coupled plasma ICP for very low concentration. So, but metals with density over 5 kilogram per cubic meter are known as heavy metals. Metals are one of the constituents or impurities often carried by water. Although most of the metals are not harmful at normal levels, a few metals can cause taste and other problems in drinking water. Okay, so common metals found in water, and you can see what are the health hazards of different types of metals. Okay, non-metallic compounds include nitrates and cyanides. They cause oxygen deprivation by binding the hemoglobin sites. Just now we talked about the blue baby syndrome that prevents the red blood cell from carrying the oxygen. The measurement is using colorimetric, tachymetric, or electrometric methods. Okay, toxic inorganic substances. Toxic organic substances. Oh, just now we talked about organic substances that most of them are not harmful. Okay, I have a few more slides. They are not harmful, but some of the man-made pollutants are toxic. Why? These include insecticides, pesticides, solvents, detergent, and disinfectants, because they have natural organic matter, a complex mixture of organic materials such as humic and hydrophilic acids, present in all drinking water sources. So the problem with this natural organic matter is they will react with the chlorine that you input in the water supply system to form disinfection byproducts. Many of DPP formed by the reaction of NOM with disinfectant are reported to be toxic and carcinogenic to humans. So let's say if you want to further your study in for your master or PhD in water supply, this is one of the area that is very interesting and also is very important. So the measurement is using chromatographic HPLC or a mass spectrophotometric method. Okay, the norm and also that will form DBP, disinfection byproducts. Okay, radioactive substances usually in groundwater. So this is example, the radon gas is of a great health concern because it occurs naturally in groundwater and is a highly volatile gas which can be inhaled during the showering process. Okay, so most of the time the radioactive substances is where you get from the groundwater. Okay. Biological parameters of water quality, you can have bacteria, single cell plants because of their cell structure and the way they ingest food occur in three base is okay, you can read through. A lot of dangerous waterborne diseases are caused by bacteria, namely typhoid, paratyphoid fever, leptospirosis. Leptospirosis is due to the rat, but this is the bacteria, tularemia, shigellosis, and cholera. Okay, you can also have algae, microscopic plants which contain photosynthetic pigments such as chlorophyll. This algae, although it is not harmful, but the taste and they will cause taste and odor problems. The algae and viruses, the smallest biological structures known to contain all genetic information necessary for their own reproduction. Parasites that need a host to live. So viruses like our our present pandemic. What is that? Now, due to the viruses and not bacteria. Apa ni kita punya apa sekarang ni? COVID-19, COVID-19 due to viruses. So they are parasites that need a host to live. Okay, the host is human lah. The COVID-19, they are viruses. Waterborne viral pathogens are known to cause infectious hepatitis and poliomyelitis. Most of the waterborne viruses can be deactivated by the disinfection process conducted in the water treatment plant. Okay, and then you can have also protozoa floating freely in water and sometimes called zooplankton, form cysts that are difficult to inactivate by disinfection. So this protozoa, sometimes if in wastewater treatment is good because protozoa, they are single cell animal that will eat up all the small particles. So the water will become very clear. But of course, you cannot drink water with protozoa. So the indicator organisms is very important because the analysis of viruses or pathogens or bacteria, it is very difficult and then time consuming, very tedious, and you need proper lab. So by having this indicator organisms, then you know that if you have this bacteria, then then you know that you need to do something with the water, meaning you have to treat, you have to disinfect. So the indicator organism is the group called Coliform Bacteria. So not all coliforms are pathogenic, but these pathogenic coliforms always exist in the intestinal system of humans, and millions are excreted with body waste. Consequently, water that has been recently contaminated with sewage will always contain coliforms. So the coliforms that is related to domestic sewage is E. coli, Escherichia coli, or E. coli. So meaning that if you become very specific, you have E. coli, then you know that the water has been contaminated with domestic sewage. Coliform bacteria are aggressive organisms survive in the water longer than most pathogens, because normally two methods to test the coliform bacteria, the membrane filter method and multiple tube fermentation method. So since the test of coliform bacteria is very important for public health, the first method will be described in details in the coming section here, so you can use if you want to test the coliforms. So if the indicator is coliform, meaning that you are it's better because you prevent any types of coliform. But sometimes they are more specific that they test the E. coli. E. coli meaning that it is sure that it is contaminated with domestic sewage. If coliform, not necessarily, but better to be careful that you will maybe you will have this pathogenic coliform. But if E. coli, then definitely it has been contaminated with sewage. So sewage meaning that it comes from this intestinal system of humans, from our waste, so it's very dangerous. Okay, students, then we finish with this slide on water sources and water quality. Actually, I thought that I have time to continue with the regulations, but I think I'll do it together with our first lesson on treatment units next Monday. Okay, so any questions from you, students? Any questions? Any questions? Okay, it's almost 10. Okay, I hope that if you know that any of your friends drop this class, please let me know, because I've already included in the slides in the overview of the course the names of students and the groups. So please let me know if any of them drop the class, and then we'll reduce the number of groups that I ask you to for your design project, because it is very important. Because when you do something, when you design your own, when you do the calculation for each treatment, and then you have to review each types of unit operation, actually you will learn better. Because you want to make sure that you understand, because you need to decide on the treatment unit based on the characteristic of water that you have chosen. Okay. Okay, see you again next week. Anything you can WhatsApp in the group. Okay. Okay. Anything? No?
No, Prof.
Okay, see you next week. Thank you.
Thank you, Prof.
Okay, welcome. Okay, welcome.